Hi guys, today we are going to be solving linear inequalities in a single variable. To solve a linear inequality, we are going to solve it the same way we solve our equations. Our primary focus is to isolate the variable terms. The only thing that we have to keep in mind is that at any point, if we multiply or divide both sides by a negative number, we have to reverse the direction of the inequality symbol. And the reason being is not because the book said so, it's actually because the math says so. So I'm going to go ahead and explain why with examples. Okay, so let's just say I'm going to compare two numbers, say 3 and 5. And then I know that you know that 3 is smaller than 5. So using our math notation, we're going to say 3 is less than 5. Now, for some weird reason, don't know why, I feel like multiplying both sides, say, by -2. Yeah. Why? Because I felt like it. As simple as that. Okay. So now the question is, all right, let's go ahead and bring down the statements. So a product of -2 and 3 is -6. Product of 5 and -2 is -10. Being the good students that we are, we bring down the inequality symbol, and then we're like, okay, let's bring it down. So our statement reads -6 is less than -10, but I'm having a moment because last time I checked, -6 is not less than -10. It's actually larger. Okay, I put bigger. Okay, it's actually larger. So in order to make this inequality, in order to make this statement true, there's no way around it. We have to reverse the direction of the inequality symbol. And this time around, it's not because the book said so, it's just because the math needs to say so. Cool. Now, similar, let's go ahead and do one for division. So I'm going to compare two numbers, say, I'm not going to get too creative, 4 and 2. I know that you know that 4 is larger than 2, so using our math notation, we're going to say that 4 is greater than 2. And for some weird reason, don't know why, I feel like dividing both sides by 2. So let's go ahead, divide both sides by 2. Oh, by -2, my mistake. So we keep our cool, we do the arithmetic. Quotient of 4 and -2 is -2. Quotient of 2 and -1 is -1. And again, being the good students that we are, we're like, okay, let's bring down the rest of the problem. So our statement reads -2 is greater than -1. So, and again, I'm scratching my head because I'm like, this is a lie. -2 is not greater than -1. It's actually smaller, okay? So in order to make this a true statement, we don't want to tell the world lies. There's no way around it. We have to reverse the direction of the inequality symbol. So that will give us -2 is less than -1. So these are things that you need to have in the back of your mind. At any point when you're multiplying or dividing, if you're multiplying by a negative or dividing both sides by a negative, we have to reverse the direction of the inequality symbol, or in fewer words, we have to flip it. Why? Because the math needs to be correct. This is something that you have to keep in the back of your mind, because let's just say you have -3x is less than 15. Okay, so to isolate the variable, we to get rid of the times -3, we're gonna go ahead divide both sides by -3. So when we do, quotient of -3 in itself will give us 1. Quotient of 15, quotient of 15 and -3 will give us -5. And then I have to remember that, let's go ahead, bust out the sirens. At any point, if we multiply or divide both sides by a negative, we gotta reverse the direction of the inequality symbol, or we'll say flip. Now, when we're comparing two numbers, it's a lot easier to see why we have to flip it, okay? Because we need it to make sense. When we have, when we're not comparing two numbers, it's very easy to forget to reverse. Let's say a few words. When we toss in a variable in the mix, it's very easy to forget to flip the inequality symbol when we divide by a negative. But when we check our answer, if we forget to flip it, then we'll realize that we have a technical difficulty. So just have this in the back of your mind. Okay, that was too much side chatter. Let's go ahead and get to the meat of this problem. Okay, so problem A. So again, how are we gonna solve it? We're gonna solve it the same way we had our equations. Ultimately we want to isolate the variable term, and just have in the back of our mind that at any point, if we multiply or divide both sides by a negative, we gotta flip or reverse the direction of the inequality symbol. So now we have variable terms on both sides. It would be nice if we have them on the same side. I'm not a mind reader, but I'm gonna try my best. I'm going to go ahead and move the x so that way we can have positive coefficients. So if you choose to subtract x from both sides, then this is how it's going to go down. Okay, so that will leave us with 3x plus 8 is greater than or equal to negative what? Fantastic. So again, pretend it's an equation and ask yourself, what am I going to do to keep going forward? So our next goal is to isolate that variable term. So if you're not with the x, you got to go. Bye. So let's go ahead and undo the addition by 8 by subtracting it from both sides, and that will give us 3x is greater than or equal to negative 9. Oh, this is such a good problem. We keep our cool. To get rid of the times 3, let's go ahead divide both sides by 3, and that will give us x. It's being compared to negative 3. I took a pause on the inequality symbol. At this point, my mind wants to say, hey, don't forget to flip it because we divided and there's a negative involved. Yeah, we did divide. There is a negative involved, but the question I want to ask you is this: did we divide by a negative? No, we did not divide by a negative. So there is no flipping. We only flip it when you multiply or divide by a negative. So in this case, we keep the inequality symbol. And I was so excited about solving these problems that I forgot to read the directions. Okay, so the directions read solve each inequality and then express the solution in interval notation. So this is the answer. Okay, it's correct. So we want all the values that are at least negative 3. But unfortunately, we are asked to write the solution set in interval notation. So if you feel comfortable going straight to the interval, you know what, go for it. But I don't. So even though we're not asked to graph the solution set, I'm still going to go ahead and graph it. Why? Because that's going to make it so much easier for me to spit the answer in interval notation. So let's do this. So we're going to do the real number line. Right now it's just a line, but as soon as you highlight any number on it, bam, we have a number line. So you can start writing the origin 0, 1, 2, 3, negative 1, negative 2, negative 3, but we have no time for that. The only one that's really crucial in this case is the number that's being compared to the variable, which is negative 3. Okay, depending on your book, you may use the open or close circle notation or the parenthesis bracket notation. I'm not a big fan of the parenthesis or bracket notation because that requires for me to think ahead. It requires for me to be like, okay, should I open to the right or should I open to the left? But the open or close circle notation, I don't have to worry about that. I just take it one step at a time. So let's do this. So we have x is greater than or equal to negative 3. So the first recommendation I'm going to ask yourself is this: is this endpoint or this number part of the solution? And that's going to be dictated by the inequality symbol. If the inequality symbol has the equal to part, the negative 3 is part of the solution. If it doesn't, cool. So in this case, we have the equal to part. So again, I call it equal to part because this symbol comes pretty much from is greater than and the equal sign, but this is too high, so someone just said let's go ahead and write it like that. Well, that's my theory. Okay, don't quote me on that. Okay, so because the inequality symbol has the equal to part, then that means that negative 3 is in, meaning it's part of the solution, so we can graph it. How do we graph it? We make a point. The book will call it a closed circle, but the way I see it, all circles are closed, right? You know, like open circle looks like this. I dug into it. You can just delete the last 10 seconds. Okay, so first things first, make the call: is the endpoint part of the solution? In this case, the answer is yes. So now the next question is, what are the rest of the solution? The rest of the solutions are the values that are bigger than negative 3. Bear in mind that this is a number line. Values to the right are larger and values to the left are smaller. So in this case, we're going to pull to the right. If you need to highlight additional numbers, like put numbers before and after, go for it. Negative 2, negative 1, 0, negative 4, negative 5, negative 6, and then do what you got to do. So again, although we're not required to graph the solution set, this is going to be very helpful for me to write the answer in interval notation. So in interval notation goes from left to right. So we start at negative 3 and we end nowhere, but we pull towards the positive direction. So we have negative 3 to infinity, where negative 3 is included. So remember, brackets if you're in, parentheses if you're out. Because the infinities don't represent specific numbers, we're always going to put parentheses at the end. So let's go ahead and box it. So in the books, this is how you will always see the answer. But sometimes what I tell students is I need to know, do you understand what this means? When we give the answer in interval notation, we're telling the reader that the solutions for the x is all these numbers in this interval. So if you want to start writing x equals, you know, the interval, so that way you know, like, well, what equals that interval? Oh, it's like, oh, the solutions for x. This is something new that I started to do, so I may forget to do this again. Okay, so let's that is our first problem. We have 2 more in the agenda. Okay, so problem B. So we have 2 times negative 7 minus x. That's a x is greater than 5x. Okay, so first things first, let's go ahead simplify each side. And again, to solve it, you solve it the same way as if it was an equation. So let's go ahead, clear grouping symbols, and work our magic to isolate that variable term. Product of 2 and negative 7 will give us negative 14. Product of 2 and negative x is negative 2x, and that is greater than 5x. Fantastic. So at this point, I may not be able to read your mind. Some students are like, okay, I don't care if we have an equation or inequality, I always want the x on the left. For me, I'm still deathly afraid of negative coefficients. So because negative 2 is smaller than 5, I'm going to choose to undo the subtraction by 2x. So let's do it. So if we go in that route, let's go ahead, add 2x to both sides. That will give us, where am I? Yeah, you know what? This blue doesn't stand out, so I'm just going to keep using the black pen. So that will leave us negative 14 is greater than 7x. Fantastic. So before we had variables on both sides, thanks to your hard work, now we have them on one side. So now let's do this. To get rid of the times 7, let's go ahead, divide both sides by 7. And then that will leave us with negative 2 is greater than x. Cool. All right. So now at this point, excuse me. So at this point, if you feel comfortable going straight to writing the answer in interval notation, go for it. I don't. So you know me, I'm going to graph. But I feel really uneasy to graph it when the variable is not on the left. If you're on it, you're like, okay, I'm going to graph it, but I don't. So what I'm going to do, I'm going to say optional. We're gonna rewrite as. So we're not gonna flip anything. Okay, flip means like you change the meaning. Like going back to my illustrations, before we had said negative 6 is less than negative 10, we knew that was a lie, so we had to flip it. Okay, we changed the meaning to the correct meaning. Negative 6 is greater than negative 10. Rewrite means you're just writing it again. Okay, all right. So when I read this from left to right, the statement reads negative 2 is less than x. But that doesn't really help me. I can't speak for you. That doesn't really help me to graph it. When I read it from the variable, it reads x is less than negative 2. And that's exactly what we're going to write. X is less than negative 2. Fantastic. If you think you may rewrite it incorrectly, then do what you got to do. Put the x, put the negative 2. Inequality is pointing to the variable, so when you rewrite it, it should still point to the variable. If not, then we have a situation. No one's gonna know how you rewrote it, whether you just like took out your SOS card or you generally reread it from the variable. So now with confidence, let's go ahead and do this. So we have x is less than negative 2, so x is strictly less than negative 2. So we do a line. We highlight a number on it, and just like that, we have a number line. So the first thing we want to make the call for is this number part of the solution set? And the answer is no, because unlike the previous problem, we don't have the equal to part. So we're gonna have to fake graph it with our fake point. Don't quote me on that. That's just how I speak. The books will say open circle, or depending on your book, you put a parenthesis. If you put a parenthesis, you are going to open it towards the actual solutions. In this case, we want to graph the numbers that are strictly less than negative 2. Again, this is a number line, so values to the right are larger, values to the left are smaller. So we're going to pull towards the left, towards negative 3, negative 4, negative 5, and so forth. So now with confidence, although I don't have to graph the solution set, let's go ahead, write the answer in interval notation. So remember, interval notation goes from left to right. We want to tell the reader we start here and end there. So we start here, which is not an actual number, but we're coming from the negative side. So we have that the solution set is given by the interval from negative infinity to negative 2, where negative 2 is excluded. So remember, brackets if you're in, parentheses if you're out. Cool. So I'll owe you one more problem, and that will be a wrap. Cool. So problem C. Let me get my paper ready. Okay, so problem C, we have 24 is less than or equal to 2/3 times x minus 5, and that is less than 36. Fantastic. Okay, so this one is a lot more spicier. We have a 3-part inequality. So the question is, how are we going to handle it? We're going to handle it the same way as if it was a 2-part inequality. We're going to handle it the same way as if it was a 2-part inequality. So this is in my way, so I'm going to temporarily cover it. Okay, there's no need for me to show my manicure. Okay, so I'm going to cover it. That looks even weird. Okay. So for me, I'm naturally inclined to clear the grouping symbols, but in this case, I really don't want to work with fraction operations. So work your magic, get rid of the fraction. To get rid of the division by 3, if we only have 2 parts, we will go ahead multiply both sides by 3. But in this case, now that we have 3 parts, we're going to go ahead multiply all 3 sides by 3. Okay, so I don't have a lot of space. That's okay. I'll squeeze it. So times 3, times 3, times 3. Okay, so go ahead, grab your calculator. Let's do this. So product of 3 and 24 will give us 72. Quotient of 3 in itself will give us 1, and that will leave us with 2 times x minus 5 is less than 36 times 3 will give us 108. Fantastic. So now I have the green light to distribute and avoid the fraction computation. So we have 72 is less than or equal to product of 2 and x is 2x. Product of 2 and negative 5 will give us negative 10, and that is less than 108. So whether we have a 2-part inequality or a 3-part inequality, ultimately we want to isolate the variable term like we did in the earlier problems. To undo the minus 10, let's go ahead, add 10, not to both sides, but add 10 to all 3 sides. So work your magic. We'll add 10 to all 3 sides. And when we do, that will give us 82 is less than or equal to 2x, and that is less than one. That is strictly less than 118. Fantastic. For the grand finale, to get rid of the times 2, we're gonna divide both. We're not gonna divide both sides by 2. We're gonna go ahead divide all 3 sides by 2. So let's go ahead and do that. Take your time, punch it in, and remember to pause and rewind as many times as you like. Quotient of 82 in itself will give us 41. That is less than or equal to x, and that is less than 59. So the variable is isolated, so we're good. But now the question is, how do I write this in interval notation? So reading it from the variable, we have that x has to be greater than or equal to 49, and at the same time it has to be less than 59. So I'm looking for the numbers that are bigger than 41 and at the same time under 59. So I'm going to show you 2 ways to graph the solution set. Again, graphing is optional. If you can just see the interval, go straight from inequality to interval notation. Okay, so I'm going to show you 2 ways to graph it. One is just going straight to graph, and the other one is by breaking it down. Okay, so we have a line. There's no number highlighted, so I'm not going to highlight anything just yet. Okay, so the numbers, so the endpoints are going to be 41 and 59. 41 is part of the solution set because we have the equal to part, so we can graph it. 59 is not part of the solution set because we don't have the equal to part. I said I was going to show you 2 ways, but I lie. Sometimes in my effort to break it down for you, I confuse you more, so I'll keep that secret to myself. Okay, so the numbers that we're looking for are the values that are bigger than 41 and at the same time under 59. So values that are bigger than 41 are to the right, values that are less than 59 are to the left. So the values that are bigger than 41 and under 59 is pretty much this sandwich right here. These numbers are the numbers that are bigger than 41 and at the same time less than 59. So in interval notation, oh, I love this graph because I don't have to use my imagination. Interval notation, we tell the reader the solutions start here and end there. So the solution set is given by the interval from 41 to 59, where 41 is included and 59 is excluded. Okay guys, so I said we were gonna knock out 3 problems. This was the 3rd problem, so we're good to go. Until next time, thank you.